Hello students, I have come up with another challenging problem for the students who aspire to go for IIT exam or for this Olympiad, physics Olympiad. The problem is like this. It is a frame, wire frame with a slider, but it is horizontal. You see, it is not on the board, it is horizontal frame like this, horizontal frame like this, horizontal, and to the horizontal frame, there is a slider, and to the slider is connected a string or a pulley, and hanging mass is also connected through the pulley to the slider like this. It is a hanging mass connected to the pulley, and the pulley is connected to the slider, and magnetic field is passing through the wire frame like this. It is horizontal wire frame, and the slider is also horizontally moving, and the mass is hanging down through the pulley by the string. Okay. When this hanging mass is just released, the slider begins to move with some velocity. Its initial velocity is 0. It begins to move. What happens through this part of the circuit? Flux changes. The moment flux changes, the flux comes out of the frame. The flux increases, and the current flows through the slider. And what is the direction of the current? The direction of the current is like this. The direction of the current should be like this. Yes. The current flows through the slider. Now the slider is in the magnetic field, because the moment current begins to flow, the slider is in the magnetic field, and there is a force, and that force is always backward to the velocity f, because the velocity is forward, because it is being pulled in the forward direction. It is a wire frame. The magnetic field passes through the wire frame, and the slider moves in the forward direction. The flux through the wire frame changes. The moment flux through the wire frame changes, there is induced EMF in the wire frame, and that induced EMF creates current in the circuit, and that current flows through the slider, and the slider is already in the magnetic field. Therefore, there should be a force. There should be a force on the slider, which is the backward direction, right? We have to find, obviously, this force will try to retard the velocity of the slider. We have to find the velocity as a function of time. So how to proceed ahead with this problem? It's mg downwards force. It creates tension T in the string. The tension is the same as on this, because this string is massless. In the massless string, the tension is the same. So let me suppose this block moves down to the acceleration a. Same will be the acceleration of this slider, right? And I want to write the equation for this here, for this block, Newton's law. This will be the net force is mg minus t. Mg minus tension is equal to mass into acceleration, Newton's law, equation number first. Let me write the equation for this slider. The equation for the slider is, how much is the force in this direction? That is tension T, minus magnetic force on the slider in the backward direction, that is F, is equal to, again, ma. Equation number second, because m is the mass of the slider. These are the two equations that we can use Newton's law for this block and for this slider. Okay. Now what I have to do, I will find first of all this acceleration of the block or of the slider, and then I will integrate the acceleration to find the velocity as a function of time. Okay. Now on adding these two equations, I will be getting rid of this tension. Okay. Add these two equations, adding the equations, we will get mg minus f is equal to a times m plus m. So what is acceleration a? That is mg minus this f, okay, divided by m plus m. This is the acceleration that we can get. Now I want to find this force, this magnetic force, third equation. What is magnetic force? Magnetic force on this slider. The magnetic force on this slider is current LB, length of the slider into magnetic field. What is I? I is the current through the slider or through this circuit. How much is that current? That is induced EMF by R, LB. What is induced EMF in this circuit? In this, when the magnetic flux changes because of the slider going forward, the magnetic flux changes. That is this induced EMF. That is VBL. That is what we know. Into again LB by R. So force is equal to, that is VL square B square by R. Fourth equation. When the slider moves forward, there is induced EMF, and that induced EMF will cause current to flow, and that current carrying slider will experience force backward direction. But what is the induced EMF? That's VBL. That's what we already have been doing about on these problems. And what's current? Current is VBL. There's induced EMF by resistance. Okay, that's right. Now let me put this force here, and let me see what happens. Okay, so acceleration is equal to, that is mg minus f, that is VL square B square by R whole divided by m plus m. What is this acceleration in terms of velocity? That is dv by dt. That is equal to mg minus VL square B square, the same, by R divided by m plus m. Now put the v terms on the left and time on the right. It is called separation of variables. We have to put velocity term here, and we have to put time term there on the right side. So what we are getting? What we are getting? Okay, now dv divided by this quantity mg minus VL square B square by R. This dv divided by this numerator quantity will go to the denominator on the left side, and dt will go here, divided by m plus m, this one. So now we will integrate. Now we are going to integrating the equation from where to where. What was the initial velocity when the slider starts moving? That was 0. What is any velocity after any time, after some time, after at some instantaneous time, suppose v. Okay, what is the initial time, starting time? That is 0. And what is final time? That is any time, that is t. Okay, now it is dv in the numerator and v term in the denominator, so it is log of mg minus VL square B square by R, ln of the denominator, divided by differentiation of this. इसका डिफरेंशिएट करना पड़ेगा, डिनोमिनेटर का डिफरेंशिएट करना पड़ेगा और लिखना पड़ेगा यहाँ पर, दैट इज माइनस एल स्क्वायर बी स्क्वायर बाय आर. इसका 0 और इसका v के बगैर जो भी है वो डिफरेंशिएशन में आता है. एंड दैट इज यहाँ पर 1 बाय m प्लस m लिखो और dt का डिफरेंशिएशन t. लेकिन यहाँ पर हमें लिखना पड़ेगा 0 टू ओके v लिमिट्स. अब इसको उठाकर यहाँ रखो on this side. So what we have to write? So that's ln of mg minus VL square B square by R 0 to v is equal to, इसको यहाँ रखिए, that is minus L square B square divided by what? R, this one, और ये m plus m यही रहेगा, m plus m into t. Right? Okay. Now let me go to the next step. Don't forget that what we are doing, we try to find the velocity of the slider as a function of time. The slider started with 0 velocity. The mass is pulling it forward, the hanging mass. When it pulls forward, the flux through the closed circuit changes. There is induced EMF and there is current. Now through the slider current flows, and the slider is already in the magnetic field. There's a backward force. So the moment it pulls on the forward direction, there's a backward force. So we have to take care of all the involved forces, and then we are using Newton's laws. Okay, now first we give the value V, that is ln of, yes, mg minus VL square B square by R minus, because I have given the value V to this ln of the expression, then give velocity value 0, that is ln of mg only, is equal to, okay, minus L square B square T divided by R m plus m, right? Okay, chaliye. Now it is ln of mn, so this is a formula, log of x minus log of y is log of x by y, log a minus log b is log of a by b. That is the formula that you know. The ln of mg minus vl square b square by r divided by this mg is equal to minus L square B square T by R by M plus M, right? Okay, now ln को शिफ्ट उस साइड कीजिए, that becomes एंटी लॉग, लेकिन mg को यहाँ भी डिवाइड कीजिए और यहाँ भी डिवाइड कीजिए, so it is 1 minus VL square B square by R, this R mg, जब मैं इस mg को यहां भी डिवाइड करूं और यहां भी डिवाइड करूं तो ये मुझे मिलेगा, और लॉग को शिफ्ट करूंगा, दैट विल बिकम e रेज्ड पावर दिस क्वांटिटी माइनस थोड़ा सा नीचे 1 माइनस VL स्क्वायर B स्क्वायर बाय R mg इज इक्वल टू e रेज्ड पावर माइनस L स्क्वायर B स्क्वायर T डिवाइड बाय R टाइम्स m प्लस m. नाउ व्हाट इज दिस V? इस टर्म को यहां शिफ्ट करो और इसको राइट की ओर शिफ्ट करो, क्या मिलेगा? व्हाट विल यू गेट? अगर मैं इसको यहां शिफ्ट करूं, सो इट विल बी 1 माइनस ई रेज्ड पावर माइनस एल स्क्वायर बी स्क्वायर टी डिवाइड बाय आर टाइम्स एम प्लस एम इज इक्वल टू, ओके, तो यहां शिफ्ट वी टाइम्स एल स्क्वायर बी स्क्वायर B square divided by R mg. ओके, अब जाकर मुझे बताइए व्हाट इज दिस V. दिस V इक्वल टू, ये यहां जाएगा, दैट इज R mg डिवाइड बाय L स्क्वायर B स्क्वायर इंटू 1 माइनस ई रेज्ड पावर L square B square T divided by R times M plus M. This is the expression for the velocity of the slider. When the slider moves, its velocity changes according to this equation. But now see here, see the beauty of the equation. If you put t is equal to 0, what will happen to this e raised to power minus 0? E raised to power minus 0 will be 1. So 1 minus 1 is 0, so velocity is 1 at time t is equal to 0, right? So the body starts with 0 velocity, that is evident, that is this equation reflects that. इस equation से वही हमें जानकारी मिलती है कि initially the body starts with 0 velocity. Of course we have, that is our condition, initial condition. But if t tends to 0 infinity after a long time, t tends to infinity, what is the velocity? V equal to, okay, R mg divided by L square B square into 1 minus t tends to infinity, it is e raised to power minus infinity, that tends to 0. So you get the velocity, finally, but after a long time, V is equal to, okay, R mg divided by L square B square. That is the answer for the slider velocity after a sufficiently longer period of time. So a slider starts with zero velocity, its velocity changes as per the expression, and finally the velocity stagnates and the velocity remains constant. At that time you can say that tension is equal to this magnetic force. That this tension is equal to magnetic force, and this tension is equal to mg. So that's all. So this was the problem, challenging problem for the students who aspire to go for the advanced IIT or JEE, and also this is good for the students who want to go for this Olympiad, national Olympiad or international Olympiad. Remain in touch. I will be delivering continuous lectures on the YouTube, and you can download my app, Tata Sir Physics Class, from the Google Store. Thank you.